What are two characteristics of modern AI speech systems that show improvement over earlier systems? Select two answers. A. Automatic translation of written emails. B. Ability to generate computer vision tags. C. Ability to ignore background noise during conversations. D. Capability to express emotions and tone while speaking. The correct answers are C. Ability to ignore background noise during conversations. D. Capability to express emotions and tone while speaking. Let me explain. Modern AI speech systems have come a long way, especially in their ability to function effectively in noisy environments. That's why the ability to ignore background noise during conversations is a key improvement. Think about when you're on a video call in a busy cafe. Modern systems can filter out that ambient noise so the AI focuses just on your voice, improving transcription and communication accuracy. Next, capability to express emotions and tone while speaking refers to advancements in speech synthesis. Instead of flat robotic voices, AI can now speak more like a human, with emotion, intonation, and natural pacing. This is essential in applications like virtual assistants or customer service bots, where sounding relatable makes a big difference. On the other hand, automatic translation of written emails is part of text processing, not speech AI. Similarly, generating computer vision tags deals with images, not audio. So while important, these features fall outside the scope of speech-specific improvements. In short, today's AI speech systems are not just more accurate, they're also more human-like and context-aware. For each statement below, indicate whether the answer is true or false. Sentiment analysis helps determine whether a piece of text is positive, negative, or neutral. True text classification refers to identifying the names of people or organizations in a document. False language detection is the process of figuring out what language a text is written in. True. The terms NLP and NLU are sometimes used to describe the same area of AI. True. Let's go through the explanation for each one. Starting with the first statement. Sentiment analysis is indeed used to determine the emotional tone of text, whether it's positive, negative, or neutral. It's widely used in analyzing customer feedback, reviews, and social media posts to gauge public opinion. Next, the statement about text classification is false. Text classification involves assigning predefined categories to text, like labeling emails as spam or non-spam. On the other hand, identifying names of people or organizations is actually a task known as named entity recognition, not classification. Moving on, language detection is correctly marked as true. It's the process of identifying which language a piece of text is written in. This is especially useful for routing customer service tickets or translating multilingual content. Finally, the terms NLP and NLU are often used interchangeably, which makes the last statement true. NLP stands for Natural Language Processing, a broad field, while NLU, Natural Language Understanding, is a subfield focusing on interpreting meaning. Although some draw fine distinctions, in many contexts they refer to similar AI capabilities. Fill in the blanks by selecting the correct options from the drop-down menus. An AI-powered facial recognition system should delete personal images once they are no longer needed and restrict access to authorized users only to uphold privacy and security standards. Now let's walk through the explanation. When it comes to responsible AI, especially in sensitive areas like facial recognition, data handling must follow strict privacy rules. That's why the system should delete personal images once they're no longer needed. Keeping them indefinitely increases the risk of misuse or data breaches. By deleting them promptly, organizations limit their exposure and respect individuals' privacy rights. Additionally, access should be limited to authorized users only. This ensures that only personnel with a valid reason can access such sensitive data. Just like a secure vault, not everyone should be able to peek inside, only those with the key. On the other hand, options like generate predictions or display all data aren't related to privacy enforcement. Likewise, applying fairness metrics is crucial for avoiding bias but doesn't address access or retention. And sharing data with third parties without proper controls is a clear privacy risk. So ultimately, deleting data when it's no longer needed and restricting access are key pillars of secure and responsible AI system design. In most machine learning models, the input features are represented as a vector. What does this mean? Select one answer. A, each feature has a separate model assigned to it. B, the features are grouped into an array of multiple values. C, each feature is treated as a single scalar value. D, the model automatically generates feature names. The correct answer is B. The features are grouped into an array of multiple values. Let's now take a moment to explain what this means. In machine learning, input features such as age, income, or temperature are represented as numbers. These numbers are bundled together into what's called a feature vector, which is just an array or list of values that are fed into the model at once. Think of it like entering all the ingredients into a blender. You don't blend each one with a separate machine. Now, option A is incorrect because we don't assign a separate model to each feature. All the features go into the same model together. Option C may seem close since each individual feature is a scalar, but the key concept here is that together they form a vector. Lastly, D is also incorrect. The model doesn't automatically create names for features. These names are defined by data engineers or analysts beforehand. So to summarize, grouping input features into a vector is a fundamental way models process multiple variables at once, allowing them to spot patterns across combinations of data. You are building a predictive model to determine whether new users will respond to a promotional email based on their previous purchase behavior and demographic attributes. Your dataset includes many past user responses labeled as either responded or not responded. What is the appropriate type of machine learning to use? Select one answer. A, classification. B, regression. C, clustering. D, reinforcement learning. The correct answer is A, classification. Now let's go ahead and explain why this is the correct choice. In this scenario, you're trying to predict whether a user will respond or not respond to an email. Two distinct categories. That's exactly what classification is designed for. In fact, this is a typical example of a binary classification problem where the label has two possible outcomes. Now, regression isn't appropriate here because it deals with predicting numeric values, like the price of a product or the number of items sold. Since you're not predicting a number but rather a category, regression doesn't fit. As for clustering, that's used in unsupervised learning when there are no predefined labels. But here you clearly have labeled outcomes, so clustering is out. Finally, reinforcement learning is more about agents making decisions in dynamic environments, like a robot learning to walk or a program mastering a game. It's not typically used for tasks like email response prediction. So the best and most direct match for this use case is classification, where the model learns from past labeled responses to predict future outcomes. For each statement below, indicate whether the answer is true or false. Softmax produces a probability score for each class in multi-class classification. True. The total of all softmax probabilities equals 1.0. True, multinomial classifiers output only the most probable class label. False, softmax is used in unsupervised clustering algorithms. False. Let's take a moment to explain why these are the correct answers. First, softmax produces a probability score for each class in multi-class classification, and that's absolutely true. When a model needs to decide among multiple classes, softmax assigns a probability to each one, helping the model select the most likely outcome. Second, it's also true that the total of all softmax probabilities equals 1.0. That's a built-in feature of softmax. It turns raw scores into a normalized distribution where all the probabilities add up to 1. Now, the third statement is false. While it might seem like multinomial classifiers output only the most probable class label, they actually produce a full probability distribution over all possible labels. The final prediction might be the highest one, but the rest of the scores are still calculated. Finally, softmax is used in supervised classification, not in unsupervised clustering algorithms, so the last statement is also false. Clustering doesn't involve labeled data, whereas softmax operates in contexts where labels are known and predictions are required. So overall, softmax is a powerful tool for supervised learning that provides clear probabilistic predictions across multiple classes. Which statement best describes the process used to train a multi-class classification model? Select one answer. A. It learns from labeled examples through training, validation, and evaluation steps. B. It generates numeric values for each output label. C. It clusters unlabeled data into groups. D. It randomly selects a predicted class for each observation. The correct answer is A. It learns from labeled examples through training, validation, and evaluation steps. Let's break this down and understand why. Multi-class classification falls under supervised learning, which means it requires labeled data to train. The model goes through phases: training, where it learns from the data; validation, where its performance is fine-tuned; and evaluation, where its accuracy is tested on unseen data. This structured process helps ensure the model makes accurate predictions across multiple classes. Now, option B is incorrect because generating numeric values for each output label describes regression, not classification. In classification, the output is a category, not a number. Option C describes unsupervised learning, specifically clustering, where the data isn't labeled and the model tries to group similar items. That's not what happens in classification. Finally, option D is off base because models don't just randomly select a class. Classification is a data-driven process using learned patterns to make an informed prediction, not a guess. So the key takeaway is multi-class classification trains on labeled examples and improves performance through structured evaluation steps. For each statement below, indicate whether the answer is true or false. A softmax function is typically used in the output layer of a classification neural network. True gradient descent helps optimize the neural network by increasing loss values. False. The weights in a neural network are randomly assigned at the start of training. True backpropagation adjusts feature inputs to improve model accuracy. False. Now let's go over the explanation. First, the softmax function is indeed used in the output layer of a classification neural network, especially for multi-class problems. It transforms raw output scores into a probability distribution over possible classes, allowing the model to pick the most likely label. Next, the statement about gradient descent is false. Gradient descent works to minimize loss, not increase it. It's an optimization algorithm that adjusts the model's weights to reduce the difference between predicted and actual outcomes. Moving on, the statement about initial weights is true. Neural networks typically start with randomly assigned weights before training. This randomness helps avoid symmetry and ensures different neurons learn different features. Finally, the statement on backpropagation is false. Backpropagation doesn't touch the input features. It adjusts the weights inside the network based on the error signal from the output. Its role is to guide the network in learning how to make better predictions, not to alter the data it receives. Altogether, understanding these core processes, softmax, gradient descent, weight initialization, and backpropagation, is key to grasping how neural networks learn. Fill in the blanks by selecting the correct options from the drop-down menus. During inferencing, the attention layer assigns weights to tokens in the input sequence, and the decoder predicts the next token based on those weights. Let's walk through why these are the correct answers. When a model is generating output, say finishing your sentence or translating a phrase, it's in the inferencing phase. At this point, the attention layer plays a key role. It doesn't treat all input words equally. Instead, it assigns weights to each token based on its relevance to the task. For example, in the sentence, "The cat sat on the mat," the word "sat" might get more attention if we're predicting the action. Now, the decoder takes those weighted embeddings and uses them to predict the next token in the sequence. It might generate the next word in a sentence or the next character in a name, depending on the task. Options like backpropagation, comparing loss values, or freezing embeddings are part of the training process, not inference. Likewise, adjusting training data doesn't occur during prediction. So during inference, attention helps the model focus, and the decoder uses that focus to make accurate predictions. Fill in the blanks by selecting the correct options from the drop-down menus. Selecting the appropriate algorithm and hyperparameter values is often an iterative process based on trial and error. Let's take a moment to break this down. The term hyperparameter refers to settings like learning rate, number of trees in a forest, or the depth of a decision tree, values that must be set before training begins. These aren't learned from the data. Instead, you choose them manually or with automated tuning. Now, the process of finding the best algorithm and tuning those hyperparameters is rarely a one-shot deal. That's why it's described as iterative. You try something, evaluate the results, tweak it, and try again. It often takes multiple rounds to reach an optimal setup. Other options like static or deterministic don't reflect the nature of this process. Static would imply it doesn't change, which isn't true, and deterministic would suggest the outcome is always predictable, which trial and error certainly isn't. Likewise, terms like random, endpoint, or scoring are unrelated to how we configure or tune models. So in practice, model development is all about learning through repetition, experimentation, and careful adjustment. For each statement below, indicate whether the answer is true or false. Azure Machine Learning offers both code-first and UI-based experiences. True Azure ML integrates with ML Flow to manage the ML lifecycle. True responsible AI features in Azure ML include fairness and explainability tools. True Azure AI Services is the preferred tool for custom algorithm training and hyperparameter tuning. False. Now let's go over why these are the correct answers. First, it's true that Azure Machine Learning offers both code-first and UI-based experiences. Users can interact with it through the Azure ML Studio for drag-and-drop workflows or through code using Python SDKs and the CLI, making it flexible for both beginners and pros. Next, Azure ML integrates with ML Flow, which is also true. ML Flow helps track experiments, log metrics, register models, and manage deployment pipelines, making the whole ML lifecycle easier to manage. The third statement is also true. Responsible AI tools in Azure ML include fairness checks, explainability, like SHAP values, error analysis, and more, helping teams build models that are transparent, ethical, and aligned with compliance goals. Finally, the last statement is false. Azure AI Services provides pre-built APIs for things like speech recognition or computer vision, not for custom algorithm training. If you're building and training custom ML models, including hyperparameter tuning, Azure Machine Learning is the preferred platform. So in summary, Azure ML is your go-to for end-to-end ML development, while Azure AI Services is best for integrating ready-made AI capabilities. Which two machine learning tasks are supported by Azure Machine Learning's automated ML feature? Select two answers. A, time series forecasting. B, image classification. C, access control configuration. D, data encryption setup. The correct answers are A, time series forecasting. B, image classification. Let's now walk through the explanation. Time series forecasting is one of the core capabilities of Azure AutoML. It allows users to build models that can predict future values based on historical timestamp data, perfect for business scenarios like demand forecasting or financial predictions. The system includes built-in methods for time-aware evaluation and data splitting, which is critical for this type of task. Next, image classification is also supported by Azure AutoML. This falls under computer vision tasks where the system can be trained to recognize and categorize objects within images, like classifying animals in photos or detecting product types from pictures. On the other hand, access control, configuration, and data encryption setup are not ML tasks at all. Access control is handled through Azure services like RBAC or Active Directory, and encryption is a storage and networking concern, not something AutoML is built to handle. So, the correct ML-focused tasks that Azure's AutoML can assist with are time series forecasting and image classification. In the context of deploying machine learning models, what does scoring refer to? Select one answer. A, measuring the accuracy of a model after training. B, assigning permissions to a deployed endpoint. C, generating predictions for new input data. D, evaluating the training loss function. The correct answer is C, generating predictions for new input data. Let's now walk through the explanation. In the deployment phase of a machine learning model, the term scoring refers specifically to the process of using the trained model to generate predictions based on new, unseen input data. This can happen in real time, like recommending a product as you shop, or in batch mode, like predicting customer churn across thousands of records overnight. Now, measuring accuracy is part of model evaluation, which typically occurs during training and validation, not deployment. Similarly, assigning permissions is related to access control and security, not model inference. And evaluating the training loss function is something that happens only during the training phase to monitor learning progress, not during scoring. So in summary, once a model is deployed, scoring is the step where it goes to work, applying what it has learned to real-world data and making useful predictions. For each prediction method, drag it to the appropriate description based on the integration method and usage pattern. Each item may be used once, more than once, or not at all. Use when predictions must be returned instantly as part of app interaction. Real-time prediction. Use when processing a table of multiple data records at once. Batch prediction. Use when predictions are triggered on a schedule or after data accumulation. Batch scoring model. Use when predictions are calculated per user action on a website. Real-time scoring. Let's walk through these answers together so it makes sense. We begin with real-time prediction. This is used when predictions must be returned instantly, like when an app needs to react quickly to a user's action, say, recommending products in an e-commerce app based on their latest click. Next is batch prediction, which is best suited for handling large volumes of data at once. Think of processing a table of thousands of customer records to predict churn risk overnight. That's where batch mode really shines. Then we have batch scoring model, which comes into play when predictions are scheduled or triggered after some data accumulates. For example, a model might score all completed transactions at the end of each day. Finally, real-time scoring is used when predictions happen in response to specific user actions. If a user hovers over an ad or clicks on a product, the model scores that behavior immediately to drive what happens next. Each method matches a specific business or operational need, whether it's immediacy, volume, or automation. Choosing the right one keeps your solution both smart and efficient. Fill in the blanks by selecting the correct options from the drop-down menus. An AI assistant typically receives system message, the conversation history, and the user prompt, which may be optimized before reaching the model. Now let's go through what these mean and why they're correct. The system message comes first and acts like a set of instructions. It sets the tone, the behavior, and any constraints for how the AI should respond. For example, it might tell the model to answer like a friendly teacher or stay within a formal tone. Then we have the conversation history, which includes the back and forth exchange between the user and the assistant. This gives the model the needed context so it can respond appropriately, rather than treating every prompt as an isolated message. Finally, the user prompt is the latest input from the user. It's the direct question or instruction that the model needs to respond to next. Other options like final output, UI layout, or chat icon relate to how results are shown, not the data sent to the model. And compute log is about back-end operations, not prompt construction. So altogether, a system message sets the behavior, conversation history adds context, and the user prompt drives the response, making AI assistants more coherent and helpful. For each statement below, indicate whether it is true or false. Responsible AI should be guided by fairness, reliability, inclusiveness, transparency, privacy, and accountability. True transparency means users should understand how an AI system makes decisions. True AI developers are not responsible once a model is deployed and used autonomously. False, inclusiveness is promoted by involving diverse perspectives in design and testing. True, let's walk through why these answers are correct. First, the idea that responsible AI should be guided by fairness, reliability, inclusiveness, transparency, privacy, and accountability is absolutely true. These are Microsoft's 6 foundational principles for building AI systems that are ethical and trustworthy. Next, transparency is about helping users understand how AI arrives at its decisions. That includes showing factors like confidence scores, which indicate how certain the system is about its output and even the kind of data it used. Now, the third statement is false. AI developers remain accountable for the systems they create, even after deployment. Just because a model is running autonomously doesn't mean the responsibility disappears. Developers must ensure continued oversight and compliance. Lastly, the statement about inclusiveness is true. By involving a diverse set of voices during design and testing, developers reduce the risk of bias and increase the relevance of the system for a broader range of users. Altogether, these principles reinforce the idea that responsible AI isn't just about technical performance, it's about ensuring fairness, safety, and trust throughout the entire system lifecycle. A data scientist is trying to build a model that understands the meaning of a word based on how it's used in a sentence. She wants to ensure the model captures not just individual words, but also how words relate to their surrounding context. Which architectural approach should she consider using? Select one answer. A. Recurrent neural networks, RNNs. B. Tokenization with stop word removal. C. Word embeddings using cosine similarity. D. Assigning static tokens based on rule-based models. The correct answer is A. Recurrent neural networks, RNNs. Now, let's go ahead and explain why this is the right choice. Recurrent neural networks are designed to process sequences, meaning they analyze words in order and retain memory of what came before. This makes them ideal for understanding how words interact in context, like identifying whether bank refers to a riverbank or a financial institution based on the surrounding words. In contrast, tokenization with stop word removal is just a pre-processing step. It cleans up text, but doesn't help the model grasp meaning or context. Similarly, word embeddings using cosine similarity give us a way to compare word meanings, but they don't consider sentence structure or word order, so they fall short for contextual understanding. Finally, assigning static tokens based on rule-based models is limited by fixed logic. It doesn't adapt to the context or learn from patterns in the data, which is exactly what deep learning models like RNNs are built to do. So if you're aiming to capture the deeper meaning behind how words relate within a sentence, RNNs are the way to go. Which two characteristics typically describe large language models, LLMs? Select two answers. A, they are trained on general-purpose text from the internet. B, they are ideal for low-compute local device deployment. C, they contain billions or more parameters. D, they are easy to fine-tune with minimal compute cost. The correct answers are A, they are trained on general-purpose text from the internet, and C, they contain billions or more parameters. Let's take a moment to break down why these are the best answers. First, LLMs like GPT-3 or PaLM are trained on massive and diverse datasets sourced from general-purpose internet text. This broad exposure helps them learn language patterns, grammar, reasoning, and even some world knowledge. Next, these models are called large for a reason. They typically contain billions or even hundreds of billions of parameters. This vast number of tunable weights enables them to generate highly fluent and flexible outputs. On the other hand, they are not ideal for low-compute local deployment. Their size demands significant processing power and memory, making edge or mobile deployment impractical without pruning or compression. Finally, while it's possible to fine-tune LLMs, doing so is far from cheap. The process often requires powerful hardware and many hours of computation, which is why many organizations prefer prompt engineering or smaller adapters instead. So overall, LLMs are big, internet-trained, and powerful, but definitely not lightweight or cheap to customize. For each statement below, indicate whether it is true or false. Generative AI is primarily used for data analysis and dashboards. False. The core of a generative AI application is the language model. True. Generative AI applications cannot be integrated with other services. False. The goal of generative AI is to create new content such as text or images. True. Now let's go through the explanation behind each of these answers. To begin with, generative AI isn't primarily used for dashboards or analysis. Instead, it focuses on producing new content, whether that's text, code, images, or even music. So the first statement is clearly false. Next, it's absolutely true that language models are at the heart of most generative AI applications. These models are responsible for understanding input and generating coherent, context-aware outputs, making them the engine behind apps like ChatGPT. Moving on, the idea that generative AI can't be integrated with other services is false. In fact, many modern implementations of generative AI are embedded into workflows, chatbots, and productivity tools through APIs or automation. Lastly, the defining purpose of generative AI is content creation. Whether it's generating marketing copy, creating images from prompts, or producing summaries, this technology is designed to generate novel outputs from input data. So in summary, generative AI is all about generating fresh content powered by language models, and it integrates well into broader ecosystems. Fill in the blanks by selecting the correct options from the drop-down menus. Azure AI Foundry enables you to build agents and customize models directly from the portal as part of its solutions component. Let's now go ahead and explain these choices so you understand why they're correct. We begin with agents. In Azure AI Foundry, Agents are intelligent entities designed to carry out tasks based on user interaction or automation triggers. These are the primary building blocks of intelligent workflows. For example, you might build a virtual assistant agent that schedules meetings or answers customer questions. Next is models. Foundry provides a way for developers to customize and fine-tune machine learning models directly within the portal without needing to leave the environment or write external scripts. This tight integration speeds up iteration and allows for immediate testing. Meanwhile, options like subscriptions, dashboards, scripts, and templates are unrelated. Subscriptions are used for billing, dashboards visualize output but aren't part of the development logic. Scripts are tools, not finished solutions, and templates are just starting points. So the correct flow is: Foundry lets you build agents and customize models, all within the same platform. What is the main role of the Content Safety Evaluator in Azure AI Foundry? Select one answer. A, to detect harmful, biased, or inappropriate content. B, to check the cost of model responses. C, to verify grammar and spelling in the AI output. D, to assess how fast the AI generates responses. The correct answer is A, to detect harmful, biased, or inappropriate content. Now let's go ahead and explain why. The Content Safety Evaluator is specifically designed to monitor AI-generated responses for any harmful, toxic, or biased content. It plays a crucial role in ensuring responsible AI behavior, especially in enterprise or public-facing scenarios. For instance, if an AI chatbot produces language that's offensive or discriminatory, the evaluator flags that issue before it reaches the user. On the other hand, option B, checking the cost of model responses, falls under billing and monitoring, not content safety. Option C, verifying grammar and spelling, is related to language fluency, but doesn't assess whether the content is appropriate. And D, assessing how fast the AI generates responses, refers to system performance or latency, which again is unrelated to safety or ethics. So while those other choices focus on performance or polish, only option A targets the ethical and safe use of AI, making it the correct answer. You're designing an NLP system that must understand whether banks refers to a person or a financial institution. Which technique will best help preserve such distinctions? Select one answer. A, stemming. B, stop word removal. C, text normalization. D, entity extraction. The correct answer is D, entity extraction. Now let's go ahead and explain why. Entity extraction is specifically designed to identify named individuals, organizations, locations, and other specific entities within text. This makes it ideal when your NLP model needs to differentiate between something like Mr. Banks, which refers to a person, and banks, which could refer to financial institutions or riverbanks. By recognizing these as named entities, the model maintains essential distinctions for context. Stemming, on the other hand, reduces words to their root forms. That might strip away important context and cause banks and banking to be treated the same way, ignoring nuance. Similarly, stop word removal is only about removing filler words like the, or is, and doesn't help with meaning at all. As for text normalization, while it helps make inputs consistent by adjusting capitalization or punctuation, it could also erase details that actually help identify an entity. So, for preserving those fine-grained differences in meaning, entity extraction is the clear choice. Fill in the blanks by selecting the correct options from the drop-down menus. A corpus is a large body of text that can be analyzed using NLP techniques. During tokenization, a token may represent a word, part of a word, or punctuation mark, not just complete words. Now let's take a moment to explain how we arrived at the correct answer. First, a corpus is a foundational concept in NLP. It refers to a large and organized collection of text, often used for training or analyzing language models. Think of it as the data set that powers many language models and text analysis tools. For example, a company building a sentiment analysis model might use a corpus of customer reviews to train their system. Next, when we talk about tokenization, we're referring to breaking down that text into smaller units called tokens. These tokens aren't always complete words. In fact, depending on the method, they can include prefixes, suffixes, punctuation, or even partial words. This level of detail helps models understand language more precisely. On the other hand, like document, sentence, or noun only are too narrow for this context. A document is just one text within a corpus. A sentence is larger than a token, and tokens aren't limited to nouns. So altogether, the most accurate choices are corpus and word, part of a word, or punctuation mark. For each statement below, indicate whether it is true or false. Words like miracle cure and anti-aging may frequently appear in spam emails. True corpora are used to train and evaluate NLP models. True TF-IDF reduces the weight of words that are common across documents. True bag of words models capture the position of words in a sentence. False. Let's go ahead and explain why each of these answers is correct. To begin with, the statement about words like miracle cure and anti-aging is true. These are classic examples of trigger phrases often flagged by spam filters using techniques like naive Bayes. They typically appear in unsolicited marketing emails and are statistically associated with spam. Next, corpora, which are large collections of text, are fundamental in NLP. They're used to train models on how language is structured, and they also provide validation and test sets to measure model performance. For example, datasets like Wikipedia articles or customer reviews serve as corpora in many NLP tasks. Moving on, TF-IDF, which stands for Term Frequency Inverse Document Frequency, is a technique used to reduce the influence of commonly used words like the or and across documents. By lowering their weight, the model focuses more on unique and meaningful terms. Lastly, the idea that bag of words models capture word position is false. Bag of words only considers whether a word exists in a document, not where it appears. So if you rearrange the sentence, the bag of words representation stays the same. This makes it great for some tasks, but not ideal when word order matters. So there you have it, each statement logically broken down. What does sentiment analysis in Azure AI language return in addition to individual sentence scores? Select one answer. A. Topic classification for each sentence. B. Named entities associated with emotions. C. One overall sentiment for the full document. D. A recommendation for action based on tone. The correct answer is C. One overall sentiment for the full document. Let's go ahead and explain why that's the right choice. Sentiment analysis in Azure AI language evaluates the tone of each sentence, but it also provides a combined sentiment score and label for the entire input text. This helps users understand the general mood of the content at a glance. On the other hand, topic classification, mentioned in option A, is part of a different service and not included in sentiment analysis. Similarly, option B, named entity recognition, helps identify things like names and organizations, but doesn't track emotions. Lastly, option D is incorrect because Azure AI language doesn't give recommendations based on tone. It only analyzes sentiment, not decision-making. So the best answer is clearly C. For each statement below, indicate whether the answer is true or false. Azure AI language's question answering can be used to build bots on social media platforms. The correct answer is true. Conversational AI models are limited to customer service scenarios only. The correct answer is false. CLU supports enterprise support, command and control, and full conversations. The correct answer is true. Modern AI solutions often combine multiple AI capabilities. The correct answer is true. Now let's go ahead and explain each of these responses in more detail. To begin, Azure AI language's question answering feature can indeed be integrated into bots that run across multiple platforms, including social media. For example, a retail company might deploy the same bot across Twitter, Facebook Messenger, and its website using this capability. Next, it's incorrect to say that conversational AI models are limited to customer service only. In reality, they are widely used in areas like healthcare for symptom triage, finance for transaction queries, and even in industrial environments for control systems. Additionally, CLU, or Conversational Language Understanding, is designed to handle enterprise-level tasks. It enables command and control systems and supports entire conversation flows, making it much more than a basic chatbot. Lastly, most modern AI solutions are a blend of multiple AI techniques. A single app might use CLU for understanding commands, question answering for factual responses, and generative AI for more dynamic replies, all working together. So overall, we can see how each of these answers reflects real-world use cases and the growing power of integrated AI. Which platform provides access to Azure AI Translator as part of a unified environment for enterprise AI operations and model development? Select one answer. A. Azure AI Foundry. B. Microsoft Learn Hub. C. Translator Studio. D. Azure Logic Apps. The correct answer is A, Azure AI Foundry. Now let's go through the explanation. Azure AI Foundry is the right answer because it offers a unified platform where enterprises can manage model development and operational workflows, including access to Azure AI Translator. This is particularly useful for organizations looking to streamline multiple AI capabilities under one environment. Meanwhile, Microsoft Learn Hub is purely educational, used for training and certifications, but not for building or running enterprise AI solutions. Translator Studio is not a Microsoft product covered in this context, and Azure Logic Apps is designed for automating workflows, not for managing AI models or translation services. So when thinking about scalable enterprise AI development and translation capabilities together, Azure AI Foundry is the correct and complete platform. You are developing a meeting transcription app that needs to convert both real-time microphone input and uploaded audio recordings into text using Azure AI Speech. Which feature ensures this flexibility in handling input sources? Select one answer. A, speech synthesis. B, speech recognition. C, custom voice deployment. D, voice model tuning. The correct answer is B, speech recognition. Let's now take a moment to explain why. Speech recognition in Azure AI Speech is designed to handle both live audio streams, like from a microphone, and pre-recorded audio files. This makes it perfect for transcription apps that must accept different input types. For instance, a meeting might have live speakers and someone might later upload a voice note, all of which speech recognition can handle seamlessly. On the other hand, speech synthesis does the opposite. It generates spoken output from text but doesn't process incoming audio. Custom voice deployment is focused on tailoring the voice used for output speech, not recognizing audio. Similarly, voice model tuning is about adjusting output characteristics such as tone or speed, and not about how the input is processed. So, when flexibility in handling real-time and file-based audio input is the goal, speech recognition is the key feature you need. For each statement below, indicate whether the answer is true or false. Real-time speech transcription requires the application to stream audio to the API. True batch transcription jobs run immediately after submission. False. The text-to-speech API allows output to be saved as an audio file. True Azure AI Speech only supports English for speech services. False. Let's now take a moment to explain why. First, real-time transcription absolutely depends on a live audio stream from the application. That's because the service needs immediate access to the sound as it happens to transcribe it in real time. However, batch transcription jobs don't begin the second you submit them. They're handled on a best effort basis, which means there might be a short delay depending on system load and job size. Now, the text-to-speech API is quite versatile. Not only can it play back the speech directly, but it can also save that output to an audio file, which is helpful for things like downloadable voice responses or pre-generated announcements. Lastly, Azure AI Speech is definitely not limited to English. It supports dozens of languages and variants, making it ideal for global applications. So, remember these key distinctions when building or evaluating speech-powered solutions. Fill in the blanks by selecting the correct options from the drop-down menus. When a filter is applied to an image using convolution, the output values are stored in a new array. This array represents the filtered version of the image. Now let's walk through the explanation together. When you apply a convolutional filter to an image, the output doesn't overwrite the original pixels. Instead, the operation generates a new array to store the transformed pixel values. That's why the correct choice here is new. The convolution process results in a fresh data structure. Next, that newly generated array reflects the modified image, which we refer to as the filtered version. This filtered version highlights features like edges, blurs, or sharpened textures depending on the filter used. Conversely, if you chose original, you'd be referring to the unprocessed image. And terms like RGB or kernel don't describe the result of a convolution. RGB is about color channels, and a kernel is the small matrix used during filtering, not the output itself. So remember, convolution transforms input into a new array, and that array is your filtered image. Arrange the key steps of training and using a CNN for image classification in the correct order. Instruction: drag and drop the items into the correct order, starting with the first step at the top. Feed labeled images into the CNN. Extract feature maps using convolutional filters. Flatten the feature maps into a one-dimensional array. Feed feature values into a fully connected neural network. Calculate output probabilities using softmax. Compare predicted versus actual class to calculate loss. Adjust weights in filters and neural layers. Repeat training over multiple epochs. Now let's explain the steps involved in this CNN training loop. First, we begin by feeding labeled images into the convolutional neural network. These images serve as our input data paired with known labels for supervised learning. Next, convolutional filters scan across the images to extract important features like edges or textures, producing feature maps. After extracting these features, we flatten the multidimensional feature maps into a one-dimensional array, preparing them for processing in dense layers. This array is then passed into a fully connected neural network, where each node is connected to the next layer, allowing for complex decision-making. Subsequently, we calculate the output probabilities using a softmax function, which helps classify the input image by assigning confidence scores to each possible category. Then, the predicted result is compared to the actual class label to compute the loss, a measure of how far off the prediction is. To improve accuracy, the network adjusts the weights in its filters and neural layers using backpropagation. Finally, this training process is repeated over multiple epochs, meaning the model goes through the full dataset several times to gradually learn and improve its predictions. This entire sequence forms the backbone of how CNNs learn to classify images. You are building a computer vision model that classifies types of fruit in images. You decide to use a convolutional neural network, CNN, for this task. What is the primary role of the convolutional layers in this model? Select one answer. A, to generate random pixel values to simulate new data. B, to apply RGB filters that boost image color. C, to match each image with a caption based on metadata. D, to extract numeric features that help the network identify patterns. The correct answer is D, to extract numeric features that help the network identify patterns. Now let's explain. Convolutional layers in CNNs are specifically designed to detect and extract meaningful visual features from images. These layers apply mathematical filters that scan over the image to highlight key patterns such as edges, textures, or shapes. These patterns are then translated into numeric values, what we call feature maps, that help the network make predictions. On the other hand, generating random pixel values to simulate new data is more related to data augmentation, not the role of convolutional layers. Applying RGB filters that enhance image color might sound image-related, but it's not the purpose of CNNs. They focus on understanding, not beautifying. Matching images with metadata or captions falls into the realm of image captioning models, not standard CNN classification tasks. So in a fruit classification scenario, the CNN's filters might highlight the roundness of an apple or the texture of a pineapple. These numeric features are what allow the model to distinguish between classes. For each statement below, indicate whether the answer is true or false. Azure AI Vision can generate captions that describe an image in natural language. True bounding box coordinates indicate the size and location of detected objects. True image classification assigns multiple tags to objects found in an image. False custom models in Azure AI Vision require thousands of training images. False. Now let's go over these together. Azure AI Vision can generate natural language captions that describe what's in an image. For example, given a photo of a dog sitting on a sofa, it might return a dog sitting on a couch. That makes the first statement true. Bounding boxes help define exactly where an object is located within an image. These coordinates describe the top left position as well as the width and height, so this statement is also true. Image classification typically assigns a single label to an image as a whole, like cat or car, rather than assigning multiple tags to each object in the scene. So this third statement is false. It's a common misconception that training custom models requires thousands of images. With Azure AI Vision's support for foundation models, you can train effective models using relatively few images. Therefore, this last statement is also false. These statements cover some of the core capabilities and limitations of Azure AI Vision. What happens automatically when you create a new project in the Azure AI Foundry portal? Select one answer. A new Azure virtual machine is provisioned. B, a billing alert is created in your Azure subscription. C, your Azure account is upgraded to enterprise tier. D, an Azure AI services resource is created. The correct answer is D, an Azure AI services resource is created. Let's break it down and understand why. When you create a project in Azure AI Foundry, the platform automatically provisions an Azure AI services resource for you. This resource acts as the foundation to run, test, and build your AI solutions within the project environment. Now, a virtual machine is not created by default. Projects in Foundry don't require VMs unless you explicitly add them later. As for billing alerts, those must be configured manually in the Azure portal under cost management settings. They are not automatically triggered when you start a project. And while it might seem like a project of this nature would require a higher subscription level, your Azure account is not automatically upgraded to enterprise tier. You stay on your existing subscription unless you take deliberate action to change it. So again, the only thing that happens automatically here is the creation of the Azure AI services resource. For each statement below, indicate whether the answer is true or false. Document intelligence uses OCR as a foundation to extract and interpret text. True semantic meaning focuses on what a word or phrase conveys beyond its literal form. True. The value in a field value pair represents the category or label of the data. False. Bounding boxes are used to associate data in forms with spatial coordinates. True. Let's now walk through each of these statements and understand why the answers are what they are. First up, document intelligence uses OCR as its starting point. That's because OCR technology scans printed or handwritten text from documents and turns it into machine-readable text, which is essential for any downstream tasks like extracting entities or categorizing content. Next, semantic meaning is all about context. When we talk about the meaning of a phrase like kick the bucket, we're not thinking literally about someone kicking a bucket. Instead, we interpret it as a metaphor for death. That's the kind of deeper meaning semantic models aim to uncover. Now, the third statement is false because in a field value pair, it's the field that represents the category. For instance, invoice date is the field or label, and 2024 to 5/15 would be the value. The original statement flips that relationship. Lastly, bounding boxes are indeed used to map spatial locations of content. If you're working with a scanned form, a bounding box helps locate where on the page a field like total amount appears, so that its value can be linked correctly. Understanding these small but powerful details is key when working with document AI solutions. In the context of document intelligence, what does a field description provide? Select one answer. A, the layout structure of a scanned document. B, the bounding box used to locate the text. C, the meaning or purpose of the field name. D, the statistical confidence in the extracted value. The correct answer is C, the meaning or purpose of the field name. Let's go ahead and explain why that's the right choice. When we talk about field descriptions, we're referring to metadata that tells us what a particular field represents. For example, if a field is labeled total, the description would clarify that this refers to the total transaction amount on an invoice. This helps both machines and humans understand the context of the data. Now, while the layout structure of a scanned document is important for organizing the form, it doesn't explain what the fields mean. That's a separate concern. Similarly, bounding boxes only provide the spatial location of text elements on a page, which is helpful for linking text to form fields, but not for interpreting what those fields are about. Lastly, the statistical confidence in the extracted value is a numeric score showing how sure the system is about the accuracy of the value it pulled out. That's useful for validation, but again, it's not descriptive in terms of meaning. So in summary, field descriptions are all about semantics, helping us understand what the field actually signifies. Match each knowledge mining component to its core function. Each item may be used once, more than once, or not at all. Extracts text from PDFs, document cracking. Adds captions sentiment to data, AI enrichment. Parses and interprets queries. Query processor, defines searchable fields. Search index schema. Now let's break down and explain each match. Document cracking is the process responsible for extracting raw text from files like PDFs. It handles opening different document formats and converting them into machine-readable ASCII text, which forms the basis for downstream processing. Moving on, AI enrichment enhances that extracted data by applying artificial intelligence. This could involve generating image captions, performing sentiment analysis, or recognizing key phrases. For instance, if an invoice says payment due in 30 days, enrichment might identify and tag this as a payment term. Next, the query processor plays a vital role in interpreting and understanding user search queries. It ensures that the search results align with what the user actually meant, not just what they typed, especially useful in natural language scenarios. Lastly, the search index schema defines how the data is structured for search. It specifies fields, data types, and how information is indexed so it can be effectively filtered or sorted. Together, these components form a pipeline for making large datasets searchable and meaningful. Fill in the blanks by selecting the correct options from the drop-down menus. A customer service agency can extract issue patterns from recorded support calls by using speech transcription and analysis, while a marketing team can use AI-powered extraction to make visual and text content searchable and indexed. Let's now walk through the explanation. The phrase extract issue patterns fits well for a customer service agency since the goal is to identify recurring problems across support calls. These patterns could include common complaints or technical glitches, which helps improve service quality over time. To accomplish this, they rely on speech transcription and analysis. This process converts spoken language and call recordings into text and then applies natural language analysis to detect trends, keywords, or sentiment, helping the team understand where customers are facing challenges. On the other hand, a marketing team often works with images, videos, or blog content. That's where AI-powered extraction comes in. This technology enables the system to detect, extract, and annotate meaningful content across visual and textual formats. Finally, the goal is to make all that data searchable and indexed. In other words, once extracted, the information can be queried and retrieved quickly, much like typing in a search bar and getting precise results from a large content repository. This entire process illustrates how different teams can benefit from AI-driven content understanding tailored to their goals. Arrange the following steps in the correct order as performed by an Azure AI Search Indexer. Instruction: drag and drop the items into the correct order, starting with the first step at the top. Ingest data from a source, crack documents to extract text and images, apply AI skills to enrich data, generate fields for searchable index, persist enriched fields to an index. Now let's break down how this process works in a real-world context. First, Azure AI Search begins by ingesting data from a source. This could be a storage location like Azure Blob Storage, where raw documents are stored. After data ingestion, the system cracks open each document to extract the text and images using tools like OCR and file parsers. Once the raw content is available, AI skills are applied to enrich the data. These skills can include language detection, entity recognition, and key phrase extraction, all of which add contextual value. Following enrichment, the system generates fields that will be used to build the searchable index. These define how information will be queried. Finally, all enriched and structured data is persisted to an index, allowing users to perform intelligent searches across the content. This fixed pipeline ensures that unstructured data becomes searchable and useful for enterprise scenarios like document discovery or support ticket analysis. For each statement below, indicate whether the answer is true or false. An Azure AI Search Indexer can be scheduled to run repeatedly without manual intervention. Correct answer: true. The same indexer must always persist all three types of knowledge store outputs: tables, images, and JSON. Correct answer: false. Azure AI Vision can output both captions and tags for the same image. Correct answer: true. Cracking documents refers to encrypting content before storage. Correct answer: false. Now let's go ahead and explain each of these one by one. The first statement is true. Azure AI Search Indexers support repeatable pipelines that can be scheduled to run automatically, which is helpful for keeping your data fresh without human involvement. The second statement is false. While knowledge store outputs include tables, images, and JSON, the indexer does not need to persist all of them. It depends on the configuration. You can choose which ones to use based on your needs. Next, the third statement is true. Azure AI Vision can generate both image captions, which provide a descriptive summary, and tags, which are keywords associated with objects or scenes in the image. This makes content more discoverable and useful. The last statement is false. Cracking documents is the process of extracting text and images from files, not encrypting them. It prepares the data for enrichment and indexing rather than protecting it.